Despite of having so many benchmarks, I still believe one area which is largely ignored is large language model evaluation. There are few techniques out there which I'm going to discuss in this video, but despite of having these techniques, I still believe that evaluating a large language model to see if it fits the purpose or if it is of high quality, low quality, what exactly the standard we need to match it up with, it is still a very murky situation out there. And hopefully in the future it will evolve. And I wish that as companies are focusing on releasing models upon models, and everyone seems to be releasing one model or another out there, they would also put some focus on the evaluation side of things. Large language model evaluation is difficult. I acknowledge that because it is still mainly an art, a technique of something which we do with hit and trial instead of a proper methodology or science. All the new models which you see every day claim to have superior performance, beating this model, beating that model. And then there are a lot of researchers out there which have their own favorite models, favorite benchmarks. So you never know what exactly is the superior model and if the evaluation has been done right and if the numbers which are being presented in the tabular form are correct or not. Then we have unique use cases for companies, and then the models differ from use case to use case, and so it becomes really hard. Whenever it comes to the real world usage, then you get to learn that okay, the model which was being touted as one of the best of the breed is not really performing because it's very hard to build high quality tests that cover the seemingly endless number of use cases with these natural language processing tasks. And then we don't really get to know or settle how to measure the performance seriously. I mean, we don't know if the model is being creative or not, or if it is too random. Which metrics do we need to agree upon? I really believe that we need a standard there in terms of metrics. Then there is a very common problem which is called as overfitting with the LLMs. LLMs consume, as you know, billions and trillions of tokens, and some of which might even include parts of the test set in some way or another. So overfitting is a really a big problem and should be catered for. And we all know that how expensive it is to build these large language models, and then I think that is where companies just shirk away from evaluating it properly and thoroughly because they look at the budget of training the model and then they say, no, the model is okay. We have built it. Let's do the minimal evaluation of one kind or another and then be done with it. So now, I mean, hopefully I have given you some background and context around why model evaluation is not really that straightforward. Now let's look at some of the model evaluation techniques which are out there. The first one which I come across is perplexity. It is sort of a lab-oriented model evaluation technique as it measures how well the probability distribution predicted by the model aligns with the actual distribution of words, and it doesn't really always correlate with human judgment, and it doesn't work well comparing the model across different tasks. So if you're doing it in lab and then you just want to do have a basic one, then go with perplexity. Then we have this general language understanding evaluation or glue, which is a collection of NLP tasks. But this glue one is okay and it doesn't really gel with the human judgment at all. Then human evaluation, humans go in, test the model on different matrices, and then come up with their own benchmarks. Of course, you cannot really rely on that because there are biases, and you never know. I mean, which one is right or which one is wrong. There could be a lot of things going around in the background. Then we have LLM evaluation, where one LLM evaluates another one, and again, you could never know if LLM is biased or not because despite of the fact that it is just a piece of software, the way they are being um, getting more and more sentient, you have to be taking this sort of thing with salt of grain. with grain of salt. Sorry. Okay, and then we have bilingual evaluation under study or blue. This looks a bit better to me, to be honest. And if I would select one, I would go with blue. Not perfect at all, but still good enough because it compares n-grams in model's output to reference output. It is sensitive to slight variations, and other variations that have improved on blue are rogue, which stands for recall oriented understudy for gisting evaluation. And then we have meteor, which stands for metric for evaluation of translation with explicit ordering. And then lastly, we have F1 score, or we also call it precision recall. This is a classic way of measuring model quality. It evaluates the balance between precision and recall. So these are the techniques available right now, and I believe that none of them really meet the standard benchmarks. We really need some focus there from the maybe the big player, or maybe someone else would come in, maybe an independent authority which would, or just like we have in Kubernetes CNCF, something like that. They should really come up with some LLM evaluation which everyone would trust. So this is it, guys. Please let me know which LLM evaluation technique or methodology you are using, and what are your thoughts on it. Very, very keen to know. And if you think that there is any other technique you are using which I have missed um, putting it on my slides, very keen to know that. Thanks for watching, and if you like the content, please consider subscribing to the channel. Thank you very much.